And so when I do that, I definitely can see that my asymptote is over here. My domain and range, I'm going to do D for domain. Remember, domain is X, so it starts close to the 0 and then continues to positive infinity. It's a little different when it's a vertical asymptote. The range in this case is all real numbers. So you can put anything with a base 10 into Desmos. So if on this one above it, I'm going to pretend you couldn't put it in Desmos because first off, it's a base 2. So what I'm going to do first is I'm going to take this and I'm going to write it without the word log. So that would be 2 to the y power equals x. So I'm going to convert it to exponential now. So when I convert it, it would be, you switch your x and your y. Okay, switch x and y. So I'm going to have 2 to the x equals y. So let's do 3 points. Let's do -1, 0, and 1. Okay, so if I put a -1 in there for my x, I would get a half. If I put the 0 in there, anything with the 0 power is 1. If I put a 1 in there, I get 2. Okay, so I switch those, but I'm going to have to switch it back to put it in this chart. So I'd have 1/2, -1, 1 to 0, and then 2 to 1. So I can go ahead and graph that, go over to the half, go down -1, 1, 0, and then go over 2, up 1. I forgot to draw my asymptote. My asymptote is right here. Finish drawing my graph. So the domain in this case, it gets real close to the 0 and continues to positive infinity, and the range is all real numbers. So like I said before, since an exponential function has a horizontal, a log function will have a vertical. So that's why we have vertical asymptotes now. So make sure we do something so you know that. Let's go ahead and go to that last page. And let's see. We're going to do this number 8 thing. Remember, we had a base of e when we talk about exponential. When we write a log with a base of e, we call it a natural log. And it is written as y equals log with a base e to the x power, or the argument is x, or you can say, oops, I forgot to do the y equals, sorry. Y equals ln of x. That's how you show it's a natural log. So if we're over here, we'd have 1 over e here, then a 1, and then we'd have e. So over here, you're going to switch them and have 1 over e, -1, 1, 0, and e to the first. So this one, this number 9, we can actually put this in Desmos. Let's see if I can get that back up. Come on. There we go. So let me, I want to do this. Okay, so I'm going to put 3 and then type in the natural log, which is ln. And then I'm going to do parentheses. Then x plus 4, close my parentheses, plus 2. So here's another example of one that I can definitely see in a graph. You can get your points, by looking, get a few points. But let me go back over here. So to find just a couple of things that we know, but we're just going to point it out. This tells us we're going to have a vertical stretch by 3. Remember, it's opposite here. So it's going to go to the left 4. And then end up 2. So that's just a review of didn't mean to use that. Some of the things we've talked about before. So to do my asymptote, I'm going to look right in here. The opposite, of course, would be x equals a -4. So at the -4, I'm going to draw my asymptote. And you can get some of those points from our graph that we did. So I'm going to do some of the ones I already wrote down. At -3.6, I'm going to go down to the -1. At -3, I'm going to go up 2. And then another one I found was at, can't even read my own handwriting, -1.35. And then I can draw that. So the range is all real numbers, because that means if you see the whole thing is colored in for your y values. For your x values, it starts at the -4, but it doesn't include it, and it's going to go to positive infinity. So hopefully that's enough to kind of get you going on those.